In this video, we'll go over how to find the x-intercepts of higher degree polynomials. We're going to work on 4 questions. The first is 2x cubed minus 16x squared plus 14x. When you have problems like these, the first thing that you should do is try to factor out the greatest common factor. As you can see, the 2, the 16, and the 14 are all even, which means I can factor out a 2. We also have an x to the third power, x squared, and an x, which means I could factor out an x, because at most, we have that x to the first, that they all have in common. And then, we need to figure out what's left. So 2x times what will give you 2x cubed? And the answer is x squared. 2x times what will give you negative 16x squared? 2 times negative 8 is negative 16, and x times x is x squared. 2 times what will give you 14x? 2 times 7 will give you 14, and x times 1 will give you x. So this is what's left. So 2x times x squared minus 8x plus 7 will give you 2x cubed minus 16x squared plus 14x. Our second step is to factor whatever is inside here, if possible. And in this case, we're going to use that diamond method. So 1 times 7 is 7, and then we have negative 8. Our goal is to find two numbers that would multiply to give me positive 7, but add to give me negative 8. The only two numbers that multiply to give you 7 are 7 and 1, since it's prime. And since the sum is negative 8, both of these numbers need to be negative. That means that x squared minus 8x plus 7 will factor into 2x times x minus 1 times x minus 7. Now I have 3 different products that are equivalent to my original polynomial. And if I want to find the x-intercepts, I have to make all three products equal to 0. Using the zero product property, we can state that 0 is equal to 2x, that x minus 1 is also equal to 0, and that x minus 7 is also equal to 0, which means that x is equal to 0, x is equal to 1, and x is equal to 7. You could either divide everything by 2 here, add by 1 here, or subtract by 7, or ask yourself 2 times what will give you 0, what number minus 1 will give you 0, and what number minus 7 will give you 0. Now we're going to take these 3 values and we're going to write them as coordinate points. Remember that we made y equal to 0. So the first point is 0, 0. Our second point is 1, 0. And our last point is 7, 0. And that's how you would find the x-intercepts to this problem. Let's go ahead and move on to the second. In our second example, we have x to the fourth minus x cubed minus 20x squared. We're going to do the exact same process. We're going to factor out our greatest common factor. Since this has a 1, this has a negative 1, and this has a negative 20, we don't have a numerical common factor. But our greatest common factor for the variable will be x squared. And we're left with x squared times x squared is equal to x to the fourth. Negative x times x squared is x to the third. And negative 20 times x squared is negative 20x squared. Now we're going to factor whatever is left inside the parentheses. I'm going to use the diamond method. 1 times negative 20 is negative 20. And then b is equal to negative 1. Now you have to think of two numbers that multiply to give you negative 20, but add to give you negative 1. The two numbers are going to be negative 5 and positive 4. So let's take these two numbers and we're going to use them to factor. So we have x minus 5 times x plus 4. So we have fully factored this polynomial, and we're going to go ahead and use the zero product property and solve for x. So let's make this whole thing equal to 0. Once again, we're going to use the zero product property and state that x squared is equal to 0, x minus 5 is equal to 0, and x plus 4 is equal to 0. Let's solve for x. In this case, x is equal to 0, x is equal to 5, because 5 minus 5 is 0, and here, x is equal to negative 4. We're going to rewrite these three values as coordinate points. So you have 0, 0, we have 5, 0, and we have negative 4, 0. We actually have to do something a little bit different with the x squared is equal to 0, but that's something we'll talk about later. For now, we're just going to focus that these are the three unique x-intercepts. In this question, we have 30x to the 4th plus 35x cubed minus 15x squared. Let's go ahead and figure out what our greatest common factor is. Between 30, 35, and negative 15, these are all multiples of 5. So I'm going to go ahead and factor out of 5. This tells me what the greatest common factor for the x term is, which is going to be x squared, because this is always the last one or the smallest exponential value. So this pretty much tells me what the x term is going to be. So let's go ahead and figure out what's left inside the parentheses. So 5 times 6 is 30, and x squared times x squared is x to the 4th. 5 times 7 is 35, and then x squared times x is x to the 3rd. And then this is a negative 3. Now we're going to go ahead and factor this. Because in this problem, a is not equal to 1, that's 6, I want to use the Xbox method. And just to confirm that I'm factoring it correctly. So 6 times negative 13 is negative 18. And then we still have our 7 as our b. And we have to come up with two numbers that multiply to give you negative 18, but add to give you positive 7. So I know that 9 times 2 will give us 18, and 9 minus 2 will give us 7. So that means 9 times negative 2 is negative 18, which is perfect. This is what we want. And now we're going to go ahead and use the box method. Here's to hoping I have enough room. And let's label our box. This is always our first term, 6x squared. This is always our last term, negative 3. Our two diagonals are the two numbers we found here. It doesn't matter which one goes where. And now let's go ahead and factor the greatest common factor for each row and column. So for this row, 6 and 9 are both divisible by 3, and they both have an x, so that's 3x. Negative 2 and negative 3 are co-prime numbers, so they have nothing in common except the 1. And since they're both negative, I'm going to go ahead and factor that out as well. 6 and 2 are both even, so I could factor out a 2. And since they both have an x, I could also factor out the x. 3x times 2x is 6x squared. 2x times negative 1 is negative 2x. Perfect. I'm on a good start. 9 and negative 3 are both divisible by 3, so I'm going to factor out a 3. 3x times 3 is 9x. Negative 1 times 3 is negative 3. Okay. That means that my factored form is 5x squared times 3x minus 1 times 2x plus 3. So that's a positive 3. And we're going to go ahead and use the zero product property. 0 is equal to 5x squared. 0 is equal to 3x minus 1. And 0 is equal to 2x plus 3. Almost running out of room. Okay, so this one's easy. X is equal to 0, because 5 times 0 squared is 0. Here, it's a two-step equation, and we could go ahead and solve for x. So we're going to add 1 to both sides. 1 is equal to 3x. divide both sides by 3, 1/3 is equal to x. In this case, we could subtract both sides by 3. -3 is equal to 2x. Divide both sides by 2, and -3/2 is equal to x. So we have 0, 0. We have 1/3, 0, and we have -3/2, 0. And these are 3 unique x-intercepts. Let's go ahead and do our last question. In our last question, we have -x to the 5th minus 6x to the 4th minus 9x cubed. All of these numbers are negative, and even if they weren't all negative, because our very first one, the one in front of the x to the 5th, is negative, we're going to go ahead and factor out a -1. X to the 3rd, because this term is x to the 3rd. Let's figure out what's left. -1 times 1 is -1, so this is going to be positive, which is what we wanted. X cubed times x squared is x to the 5th. -6, this is going to be positive because we're going to multiply by this -1. And it's going to be 6x, and this negative will also turn positive, and it'll be times 9. Let's just go ahead and confirm, just to make sure that this is correct. -1 times +1 is -1. X cubed times x squared is x to the 5th. Okay, good so far. -1 times +6 is -6. And x to the 3rd times x to the 1st is x to the 4th. And -1 times +9 is -9. And x to the 3rd times 1 is just x to the 3rd. Okay, so this is our factored form. Let's use our diamond method to factor this further. 1 times 9 is 9, and b is equal to 6. So we need to come up with 2 numbers that multiply to give us 9, but add to give us 6. Those 2 numbers are 3 and 3. So we have -1 x to the 3rd times x plus 3 times x plus 3. We could rewrite this a little bit differently. So we have -1 x to the 3rd times x plus 3 quantity squared. So let's just focus on the unique factors when we make this equal to 0. So we have -x to the 3rd is equal to 0, and we have x plus 3 is equal to 0. So what number raised to the 3rd power will give you 0, and that's going to be 0. So in this case, x is still 0. Over here, what number plus 3 will give you 0? In this case, it's -3. So our 2 unique x-intercepts are x is equal to -3 and x is equal to 0, which means that our 2 x-intercepts are 0, 0, because y is equal to 0, and -3, 0. So in this problem, we only have 2 unique x-intercepts. And that concludes how do you find the x-intercepts from a higher degree polynomial by doing the GCF first, factoring what's left in the other parentheses, and then using the zero product property to find the x-intercepts.